Good morning, children. Today we are going to see an activity. Okay. Which activity? Refraction of light through a rectangular glass slab. Seeing these apparatus, you will be able to identify things, I think. No, this is a rectangular glass slab. One pencil, sharp pencil, one eraser. I have taken one protractor, one ruler, and then some pins. Okay. So the aim of this activity is to find the refraction of light through a rectangular glass slab. So in physics experiments, if you see, first is aim. The second one is apparatus required. So we have seen what are all the things needed. So shall we start with the procedure now? What to do? Now usually while doing this activity, we should take the center of this page. Okay. So what should we do? We should take a sheet like this. We should, with the help of a scale, we can draw a line from this corner to this corner and this corner to this corner, so that we will get the center. After getting that center, we should place the prism in the middle like this. Okay, that can also be done, or directly also you can do that. If it is difficult for you to get the center, you can use that, or you can directly keep the rectangular glass slab in the center, and we should draw the outline of this rectangular glass slab. After drawing the outline, I should name it. Okay, I will name it as A, B, C and D. I have named it. And then I should also label this, what I have taken. This is a glass slab. I should also write down what is the medium. What is this medium? This is air. Which is this medium? This is glass. I have kept the glass, so glass. And again it is coming out, that is air. Okay, rarer medium and denser medium we have studied. Okay, I am just marking a point and I will take it as a normal. See here. For normal, usually we will put dotted lines, so I am putting dotted lines and I will label it as N dash. Okay. Now I'll place the glass prism like this again. Okay. Now with the help of a protractor, I'll take 30 degrees. Okay. From here I should take 10, 20, 30. Or you can also keep the protractor like this and then you can measure 10, 20, 30. Okay. Now what I will do is, I will draw a line and this point I will mark it as O. And then I will place 2 pins. Okay. I'll place 2 pins and then I'll keep the glass slab like this. Now, if I see through the other side of the glass slab, I'll be able to see here. I'll show it to you. If I see through the other end of the glass slab, see here. You can see the image, this side. Okay. So this image I should see. and then I should put 2 more pins in the other end. I'll put that and then I'll show it to you. Okay, 2 pins we have put, and after seeing that, all the 4 should be in a straight line. Okay. Now after placing the pins, I should mark it, no? So I will remove it and I will mark that. This also I will remove it and I will mark it. So this point and this point. I'll remove this and also the pins. So this is first pin and this is second pin. So I label it as E and this I label it as F. Okay, and this is angle of incidence I. Okay, now these 2 pins I have marked, no? We will name that also G and H. Now we will connect G and H. The point where the G and H we are connecting now, that we will mark it as O dash. See here, this I have taken it as O and this I have taken it as O dash, and here I will draw one normal. The first normal I named it as N dash. So this I will name it as M dash. Okay, and now I will join O and O dash. See, O and O dash I am joining. So this ray, this is incident ray, this is the refracted ray. So this I will show it as R because this is angle of refraction. Then again when it comes here, this is angle of incidence and this is angle of refraction. But this is angle of incidence, this is which one? Angle of incidence. This is angle of refraction I said. Incident ray, refracted ray, and this is emergent ray. Okay. One more thing what we want to check is, in case if light travels in a straight line, see, I should keep like this. This incident ray is there, no? That straight line, I should put a straight line, dotted lines. Okay, so this is the straight line. Actually it should come like this, but because of refraction, this ray, that is the incident ray, has refracted little, and then while coming out, no, from denser medium to rarer medium, see here it is very clear. When it is moving from rarer medium to denser medium, it is moving towards the normal, and when it is moving from denser medium to rarer medium, it is moving away from the normal. So now again I will see, exact 30 degrees. So angle of incidence is also 30 degrees. Angle of emergence, this is emergence, no? Emergence is also how many degrees? 30 degrees. So angle of incidence is equal to angle of emergence. With the help of this activity, we came to know that angle of incidence is equal to angle of emergence. But the refraction, if you see, it is only 20 degrees. So it tells that angle of refraction is lesser than what? Angle of incidence. Okay, that is also proved. And one more thing I left out now. Here, what is this distance? This is called as lateral displacement. Right? You have studied the meaning for displacement. What is displacement you have studied. So, this between the distance between the emergent ray, actual emergent ray and the actual line, how it should come, no? This is called as what? Lateral displacement. We can also try this with, here we have tried with 30 degrees. See, with the help of 30 degrees, we are able to get 30 degrees. Incident, if it is 30, emergent is also 30. In case if we go for 45 degrees, angle of emergence, if you check, it will be 45 degrees. If you take 60 degrees here, this will also be 60 degrees. Okay, it's clear, I think. When you are mentioning here, this you can mention it as I1 because it is the first incident ray, angle of incidence, and then angle of refraction. Here we can take it as 2, R2, and we can take this as I2. Okay, so this is how refraction of light takes place through a rectangular glass slab. Bye.